Okay, let me continue. This is shows the table of the resistive value, how we interpret the resistive value to the materials, the ground material. For example, here we have sedimentary rock, we have igneous metamorphic rocks. But when you see this value, there is overlapping in terms of value. Let's say we got 300 meter. What type of material is that? So mean that here, to interpret that value, you have to know first what is the formation of the study area, what type of rock of the study area, what is the soil profile of the area, the soil cover of the area, and then what is the groundwater table of that area. If you get that information, then you're able to interpret better. So, meaning that here, resistivity alone is you have to combine this technique with the other technique, for example, borehole, to do the calibration or correlation value of your result. Sometimes, because of that information here, is just brief, brief to be because we have overlapping value. For example, here clay. Clay here we have 1 to 100. Just imagine, it depends on the how the moisture content. Here it 10 to 800. So it definitely is depend on type of mineral, type of moisture content. In terms of moisture content, we have a certain water content. They have iron content. Yeah, the dissolved iron, total dissolve and total dissolved solids. Yeah, some groundwater have a high total dissolved solid, some of low. Then influence the resistivity value of the groundwater. So if you have marine water, normally very low, 0.15. So then here, based on that value, if you're working, if you do this resistivity study on the alluvium or quaternary deposit, then you are able to tell people where is the groundwater area based on this information. Or you can, based on that information, you can see where is the saltwater intrusion. Yeah? Because the contrast value between the clean water and marine water. Okay. But for this igneous rock, is rocks normally they hugely depend on the groundwater table. If we have very shallow groundwater table, even we have rock underneath, then our rock is very highly fractured. Normally our resistivity value will be very low, up to less than 100. So then resistivity will be able to determine depth, thickness, and geological strata, and detecting the groundwater or contaminants or any buried waste or mineral explorations. Yeah. Sometimes you can use continuing the current fracture foundation. This is the resistivity alone is not cannot be used to for this application, but you have to support with the other informations. For example, boreholes, observations. Then the most important is the borehole or drillings. So advantage is good vertical horizontal solution, resolution, and mapping depth up to 1.4 quarter of the area length, and then the various measurement protocol. We have various measurement protocol, but I'm not discuss this protocol here. Just name it as a gradient. We have Schlumberger, we have a Werner, we have pole dipole. So this is common protocol that we are using in the field. So there is detail on the protocol, but I'm not discussing here. So this event require intrusive contacts, or we have have a nearby buried pipe or any conductive material, or effective increase in the very low. Okay. So another technique is called GPR, ground penetrating radar. That technique is using the electromagnetic wave that we inject to the ground, and then the wave will reflect if we have different in the electromagnetic properties of the ground, and then received by the antenna. So the reflected wave due to the variation of electrical properties or conductivity or electric permittivity of the material, that, and then the propagation of electric energy is attenuated due to the electric conductivity of the material. And normally GPR equipment in the market of the frequency between 25 MHz to 1 GHz. If you have low frequency, means your equipment can able to penetrate deeper compared to 1 GHz is for shallow detection. This is an example of the GPR works they put in here. So normally here we have the radar, receiver and transmitter and receiver is here, and then this card. Then they pull it this way, and then if any, because that material is they have different electric properties, or different electric conductivity or dielectric permittivity. So if we have different properties, then these wave will reflect to the surface. So deflection is can see is looks like this, echo like this. This is hyperbola. So this hyperbola shows mean this is something underneath here. So this one show depth. This is distance. So depth and distance, so you can know what is the distance of this. If the pipe here, so means you know the depth of the pipe. Okay, the pipe and the ground is different in terms of the conductivity and permittivity. So you can see the very huge contrast of this of the material. So the concept is like that. So we have this transmitter and receiver on the ground, and then able to detect this layer or this pipe. So this is example of these studies work that we conduct in the field. So yeah, if we have pipe or cable, electric cable, we can see from the image or reflections. So this is how it looks like. So this is close up of this very single wave. So it's a combination of it. Just imagine there is amount 185 different trace. This trace 185 trace. You combine that trace, it's like a reflection. As I mentioned, a reflection technique. So they have a lot of 185 trace that we collect along this one. Then they combine it. Then we can see these any reflection here. They can show it. Yeah. So from that we can able to see the utility, however, any material that have different electric conductivity or permittivity. So the last technique is gravity. Gravity is to measure the change of Earth gravity field because of the change in density of rocks that affect the acceleration of gravity, and the theory is based on Newton's law and gravity of the gravitation that stated that two mass of point and attraction force of each other. So meaning that here, if you have this equipment able to measure the change of density, the density of the soil. Here, this area is less than compared to that area. So meaning that here we able, because the hollow here, we have different materials, then that equipment able to see the change in gravity. So based on that, when they do this survey along this line. So from that survey, they're able to see the differences in terms of the gravity value. So with that, they can able to interpret this area is maybe is cavity, or if they investigate the ore, iron ore or any ore. So iron ore normally very high density, so high density or low density, so able to tell something, or they look on the basin or any filling material. So faults area, any differences in terms of the density, so that it will able to detect it. So that's the best of this gravity. Yeah, then we have a few technique. Then we have to combine. Sometimes we need to combine the technique to see, to confirm, or to enhance our understanding, to model the grounds. So, in terms of the site investigation stage, we have another stage. The last is construction stage, which is when we have in the construction stage, this is actual, that you can see the ground truth. So then we have to, if we have any change in our preliminary study or in our site investigation, then we have to we can change our design back. For post construction, we can monitoring our our structure based on the parameters that we get from the site investigation. Okay, I think that's all. Thank you. Gracias.